video is about an application of limits to infinity. It's about logistic functions. These have wonderful applications in terms of modeling populations of species and stuff like that. So, a logistic function with lots of letters in there that we can fill in specific values for, m over 1 plus a e to the minus t, where m, a, and k are all going to be positive constants. K is going to be thought of as time here. So an example that we'll work with is ours will have it be 2000 over 1 plus e to the minus 0.1 times t. And so let's suppose that this equation, that this formula here, gives the number of birds present on an island after t years. So if you plug in t of 0, that's, let's say that t is, we're counting from the year 2019, so t of 0 is how many birds there are this year. We do a survey next year, a census, and t of 1 is how many birds there are next year, t of 2 is how many birds there are in 2021, so on and so forth. And so the question is, in the long run, how many birds are there? So in 100 years, in 1,000 years, if nothing changes, can we predict how many birds are going to be living on the island in any given year? And so if we graph it, the graph looks something like this. So first off, so there's some things I want to fill in. So first, let's plop in p of 0. How many birds are there right now? 2,000 over 1 plus e to the 0 is 1. So 2,000 over 2 is 1,000. So right now, there are 1,000 birds. As it turns out, the graph is going to look something like this. That the rate that the bird population is going to increase quickly, but then it's going to slow down as it gets closer and closer and closer to 2,000. And as I hinted at when I drew that dashed line there, there's going to be a horizontal asymptote at 2,000. So basically what this is saying here is that the limit as t goes to infinity of p of t is equal to 2,000. So in the long run, how many birds are there going to be? There's going to be about 2,000 birds. In order to see how this limit works, how to see that this limit as t goes to infinity of p of t is in fact 2,000, from the formula here, all we have to do is do the limit as t goes to infinity of 2,000 over 1 plus e to the minus 0.1 t, and realize that the only thing that depends on t is the e to the minus 0.1 t part there. So rewriting this by various basic limit laws, limit as t goes to infinity of e to the minus 0.1 t, and as t gets bigger and bigger and bigger, minus 0.1 t goes off to minus infinity. E to the minus infinity is getting close to 0. So 2,000 over 1 plus 0, which is 2,000. So as it turns out, this form of what's called a logistic function is very, very popular. It's about the first model you see if you're doing modeling population dynamics, and we can find the carrying capacity. So in the long run, there's about enough food and space and shelter and all that good stuff to hold about 2,000 birds on the island.